Hi, good to see you again. Welcome to Block 2, Solving Problems with Multiplication and Division. Lesson 13. I'll share my screen. So, in your previous lesson, you learned how to solve different problems using your knowledge of finding the area of rectangles and parallelograms. In today's lesson, you're going to learn how to solve different problems using your knowledge of finding the area of triangles. Support our mission to educate the global population of children regardless of their economic circumstance by liking the video, sharing the video with those you think could benefit, subscribe to the channel, and then click on the notification bell so that when new videos are released, you will be notified. Thank you. Before we start, I would like you to do the retrieval practice questions in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here, half times 4 is 2. Half times 7 is 3.5. Half times 14 is 7. But you may be thinking, why do we have these answers? Well, take note that if we were to have a bar model, for example, and then we have halves, so 4 halves, you would notice that each pair of halves will be equal to 1. So if each pair of halves is equal to 1, it means the 4 halves will be equal to 2. And it's that same knowledge that we can apply to know or to be certain that half times 7 is 3.5, and then half times 14 is equal to 7. Well, notice that 14 divided by 2 is also equal to 7. So something you should learn from here, if you didn't know this already, is that to multiply by half is the same as dividing by 2. To multiply by half is the same as multiplying by 2. For question 2, you were asked to work out the area of the rectangles. Well, this one is quite straightforward. That is 12 times 5. Remember, the area is length times width, and that gives you 60 centimeters squared. The square is a special one. All the sides are equal, so it means the other side has to be 3. So 3 times 3 is 9 millimeters squared. Now, let's do some new learning. If you're given this square grid and then this triangle is drawn on the square grid, what would you say the area will be? Well, if you think about it, there are parts of the triangle that do not have full squared. So, but we can see that there are half of the square. So when we pair them up, we have 6 full squared, 1, 2, 3, 4, 5, 6. And each pair of these half squares would give us 1. So this pair and that pair will give us 2. So 6 add 2 is 8. So that's 8 centimeters squared. But if we have the dimensions and we do not have the grid, how do we calculate the area of a triangle? Well, we use a formula. Just like we learned that the area for a rectangle is length times width. The area for the triangle is half times the base times the perpendicular height. Okay, so perpendicular height, take note of that. Yeah, exactly like we would have perpendicular height for parallelograms. Okay, so remember that. So why I am showing you this is to help you understand why we have this formula. So think about it. If we have a square actually drawn and we have the square cut into half, how would you normally calculate the area of the square? Well, you would say base times height or length times width. But remember, we want to find the area of this triangle. So we can say, well, we'll find the area of the square and we have it. that's how we came across this formula. So the area of a triangle is half the area of a square. So half times the base times the height. And of course, for this one, the answer is 8 centimeters squared. Let's look at this one. We're now going to apply the formula. So we know that the area to find the triangle is half times the base times the perpendicular height. Here we can see that the base is 4 meters, and the height, the perpendicular height, is 9 meters. So if we apply the formula, it's going to be half times 4 times 9, which is 18 meters squared. What about this one? We do not know the perpendicular height, but imagine if we were to draw imaginary lines, we would see that they actually have the same height. So remember, the perpendicular height is the height that can make a perpendicular 90-degree angle with the base. And we can see that there. Okay? So it means the height is also 9 meters. Let's look at this one. Can we have a perpendicular height? Of course we can. It has the same perpendicular height. And we can also draw a perpendicular height here. It doesn't matter. The perpendicular height could have been drawn here. Right? Here. So for some people who are a bit fussy to say, no, it should be at, the point. Yeah. So they have the same perpendicular height. So what you should know is that the perpendicular height is the height that makes a 90 right angle or 90-degree angle with the base. Pause the video and answer questions 1 and 2. You can take 3 minutes to do these. Assuming you've paused the video and you've answered the questions, here are the answers. Here you asked, find the area of 3 triangles. Now, notice that they all have the same perpendicular height, although they are different. They look like different forms of triangles. So they're going to have the same area. And then you're being asked, what do you notice? Explain why this happens. So they have the same area because the bases and heights are the same. So you can see the bases are the same and they have the same perpendicular height. And then question 2, what is the area of the triangle? Again, we do the base times the perpendicular height, and that gives us our answer. All right. For B, you're asked to discuss with someone you're studying with, if you're studying with somebody. Okay, let's do some new learning before we do the next set of practice questions for this lesson. If we're asked to find the area of this triangle, what would we do? Have a think. Well, I'm sure you thought about this, that we'll do half times the base times the height. So it doesn't matter what order we use, we'll get the same answer. Whether it's 15 times 4 we did first before we divided by 2, because to multiply by half is the same thing as to divide by 2. So our answer will be 30 millimeters squared. What about this one? Well, some of you may have done it in different ways. The first one that is obvious is the 12 times the 6, because that is the base and the perpendicular height is the 6. So which will give us half times 12 times 6, which is half of 72, which is 36. But imagine someone else may have spotted the other one, that, well, 9 is the base. So if we were to flip it around, we'll see that 9 is the base and 8 is a perpendicular height to 9. Again, that will give us 36 meters squared. So sometimes it is useful to be very observant to see whether the orientation of the shape has changed from what is you would normally see where the base is resting on a horizontal line. All right, let's look at the example where we can find missing sides. Okay, either the missing side or the missing perpendicular height. So here is this example. We're told that the area is 18 millimeters squared, and we're asked to find the height. Again, we just need to state the area, the formula. So we present everything as it is. We know that half of 9 is 4.5. So you can see that this looks like an equation that you have seen before if you've been following our lessons. So we can do inverse operation to find the height. So in this case, we'll do 18 divided by 4.5, which will give us 4 millimeter. So whenever you are given a question where you're required to find the missing, either the missing height or the missing base, you must set your work out, write the formula, and then use inverse operation to find the missing height or base. All right, so what you've learned so far is you have made progress to know that you can apply the formula to find the area of a triangle, and you can extend your learning. You extended your learning to find the missing base or the height by using inverse operation. Pause the video and answer question 3 in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here, we'll do 16 times 23. So here you can apply your knowledge of multiplying integers. You can see how everything is linked as you study maths. One skill leads you to be able to do something else, and it helps you do it efficiently. Here, you can see the base is 8 and the height is, perpendicular height is 15. Here we can see that the here we can see that the base is 32 and we have a perpendicular height. If we were to project it here, it would be 32 times 17. Okay. Here we see the perpendicular height is 12 and the base is 29. So you just multiply them and then you have your answer. Okay. All right. Pause the video and answer questions 4 and 5 in 3 minutes. All right. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So here you're required to find the missing side. So you're given the area. So let me write something for this one. I've been doing a lot of talking, so let me do a bit of writing. So we do half times the base times the height. We know the area is 70. So we know 70 is equal to half times 14. It doesn't matter which one we write first, times x. So we know half of 14 is 7. So 70 is equal to 70 times x. 7 times x. Made a mistake there. I'm rushing because I don't want this video to take so long. All right. And then next, to get x, we need to divide 70 by 7. This one, we can see the perpendicular height is 16 and the base is 23. So we're told to work out the value of the length marked h. So they have the same area. So first you find the area of this one. So half of 16 is 8. 8 times 23. So 23 times 8. 8 times 3 is 24. We write 4. We carry 2. And then 8 times 2 is 16. Plus the 2 we carried is 184. All right. So the area, if they have the same area, it means this is 184 centimeters squared. Now, we know that to find the area of this is going to be 25 times h. Okay? Now, to be able to get h, we know the area is half. So, area is half times, so we know the area is 184. Half times 25. Yeah, let's do it that way. Half times 25. All right, times h. Okay, we're looking for h, which is the perpendicular height. All right, now we know that half of 25 is 12.5. So half of 25 is 12.5. So 184 will be equal to 12.5 times h. Now, to get h, we'll do 184 divided by 12.5. You could use a calculator to do this, all right, if you don't want to spend so much time practicing your skill of doing division. Okay, let's move on. Pause the video and answer questions 6 and 7 in 3 minutes. All right, assuming you've paused the video and you've answered the questions, here are the answers. So here you were asked, what fraction of the large triangle is shaded? Okay, so to be able to find the fraction of the large triangle that is shaded, we can do some, calculations. We can say, well, let's find the area. The area is half times, so area, need my pen. So area is half times the base times the perpendicular height. What's wrong with my pen? So, so we're looking for the area of the big triangle, right? So the base is 12 and the perpendicular height will be 7 plus 4, which is 11. So we say half times 12 times 11. Half of this is 6. So it means 6 times 11, which is 66, is the area of the big one. Yeah, 66 centimeters squared. Now, if we now use this as our perpendicular height for this one that is shaded, so it means we'll have 7 times 6. Okay, 7, because if we want to write this, it means we're flipping this blue one over to find what the area is. So we can do, or we can just find the area of this one and then subtract it from the full one. So we can do it in different ways. So let's just do the small one, the one that is not shaded. So we'll do area is half times 12 times 4. So 4 times 6 is 24. All right. So we're being asked what fraction of the large triangle is shaded. So to know the part that is shaded, we'll do 66 minus 24. 6 minus 4 is 2. 6 minus 2 is 4. So the fraction that is shaded, the part that is shaded is 42. Now to do the fraction, we do 42 divided by 66. Okay. Now you can see that 6 is a common factor because 7 times 6 is 40. 7 times 6 is 42. So 42 divided by 6 is 7. 66 divided by 6 is 11. So the fraction that is shaded is 7 over 11. So take note of how we've done these, okay? So all these different methods we use. So this one is this one here, okay? And then this one here is the whole thing, yeah? Calculated the whole thing. Okay, the rhombus can be divided into two triangles. Find the area of the rhombus. So if we can divide it into two triangles, all right, let's say we do this, all right? So it means the base is 8, all right? And the perpendicular height will have to be half. So remember, the area is half times the base times the height, yeah? So we can see the base is 8. You can see it corresponds with the top bit there, times 5, okay? Half of 40 is, because you can see it's 40, is 20. But don't forget, we've split it into two parts. So 20 centimeters squared is one part. The other part is also 20, so it's 40. Yeah? Okay, this one you were just asked to discuss it. How can you work out the area of the shaded triangle? So this is similar to the exercise we did, which is this one here for question 6. So you will find the area of the big triangle. So I'll just discuss it. So the base is 60 times the height. You can see this is 45. All right. And this one is 35. So the full height, you add this one, you multiply it by 60. That gives you the area of the whole big triangle. Then if I were you, I'll use this base times this perpendicular height to find this one that is not shaded. Then I would subtract this from the area of the big triangle, the whole lot that we've done. And then whatever is left would be that number divided by the area of the big one. Yeah. And that will give us the fraction. That brings us to the end of our lesson. So what we've learned so far in this lesson is how to find the area of a triangle. So to find the area of a triangle, you focus on using your knowledge that you multiply the base times the perpendicular height and you divide by 2. You will see often that it is written as base times height times half, or half base times height. But it's the same thing as multiplying the base by the height and then you divide by 2. You extended your learning to learn how to find the length of missing base or the missing height, perpendicular height. And you also extended your learning to know how to solve the problem of composite triangles when you have triangles one on top of the other. Well done for taking your learning seriously and for sticking around. Until next time, take care of yourself and bye-bye.